We have a particularly talented group of people on stage today talking about a wide variety of topics, so hopefully we have enough time to do everything justice. But if you want more afterwards, I'm sure they'll be around for a conversation. I'm Siraj Khalik. I'm a partner at Atomico, focused on frontier tech investments. And we're lucky we're an investor in Grant's company, for example. And really we believe in entrepreneurs making a difference to the biggest problems in the world. And I don't think it gets much bigger than climate. So we're going to hear about 4 separate initiatives, all making an impact today. And without much further ado, let me kind of hand it over to you one at a time to briefly introduce yourself, your company, and then also what stage you're at, how many people you're at, and how far away from production you are.
Yeah. So I'll kick it off. My name's Grant. I'm the CEO, co-founder of Fabric Nano. Siraj is on our board, great investor. We just raised our Series A. We're about 20 people. We've been around for 2.5 years. We started out in the biscuit factory, an EF company underneath the highway for our seed round, and then we finally moved out of our old lab space. I think some of the people in the audience know what I'm talking about. The company, Fabric Nano, is making chemicals using biology, but we don't use typical systems. We don't use microbes. We actually use the proteins inside the microbes to do the chemistry. And so that space is called cell-free. We're a cell-free biomanufacturing company, and we can talk about that more as we progress, but that's a brief intro from us.
And how big are you? How many people?
We're about 20 people right now. Yeah.
So I'm Benjamina. I'm the founder and CEO of Higher Stakes. We're also about 20 people. What we do is we make meat using cell culture technology. So some of you might have heard about it this morning. The way it works is that we take a small sample of cell, which we expand and guide to become different types of tissue to recreate meat, focused on pork belly and bacon as first meats.
Hi, I am Shara Tiku, and I am the co-founder and CEO of C16 Bio. We have a platform for producing next-generation ingredients, which can take the most unsustainable components out of our consumer products supply chain. So that's personal, home, and food care. And we're focused on oils and lipids. Our first product is palm oil, and we got started in 2018. We are 26 people based in New York City.
Hi, my name is Anastasia Krivoruchko. I'm the CEO and co-founder of a company called Milton Marble, which uses synthetic biology and fermentation to produce animal-like fats for plant-based foods. And we are pretty early stage, so we just got our first funding round a couple of months ago, and we are 6 people right now and growing.
Awesome. Thanks for joining. I know many of you have flown from long distances to be here. So we've got 2 companies using fermentation to produce oils. We've got 1 company using cell-free to produce chemicals, and then we've got synthetic meat. And so broad cross-section. Thanks for joining. So this is a climate tech conference. The obvious question is, well, why is what you're doing important for the environment? What kind of impact would success for your companies look like for the world? We start in order. Yep.
Sure. So I think it's important to say, most materials you use in everyday life, you have wood, glass, concrete, but a lot of the things that are not in those categories are petroleum-based products, and we use $5 trillion worth of products annually. And so what our company is trying to do is we're trying to enable consumers to buy commodity scale or commodity-priced chemicals that are made from biology. And that's traditionally been a very, very hard problem. That problem dates back to the clean tech revolution, where we tried to use microbes. We tried to use yeast to create these chemicals, but those technologies failed at the time. And so we think that the future is to take the proteins from inside these miniature factories called yeast and to use those proteins to do the chemistry without the yeast. And why we think that's so important is because there's a lot of waste that goes on when you use a cell-based system. Only about 40% of the input sugar gets converted to your downstream chemical. And all the rest of that sugar is used on central carbon metabolism. It's used for respiration. And that ends up releasing a lot of CO2 into the atmosphere from the actual fermentation process. So fermentation has its place. It's a beautiful technology. But it hasn't really cracked the secret code of how to make chemicals under about $2 or $3 per kilogram. We think that's where cell-free can really make a difference. And those technologies, the products in the commodity sector, they're really important in terms of reducing GHG emissions. So I can give one example. I won't try to take up too much time, but our first product is trying to take waste glycerin streams and convert it to something called 1,3-propane-diol, very specific chemical. It's a monomer diol. It can be used as a glycol replacement in shampoos and toothpaste. It can also be used to extrude out a bio-PTT plastic, this chemical, this monomer, and it can also be used to make bio-based nylons. And so this chemical alone is $100 billion worth of market cap that we just need to crack by making it with a cell-free system. And when we do that, we're going to reduce the cradle-to-gate ratio from about 5 kilograms of CO2 emissions to 1 kilogram of product. We think we can bring that not only to 2.5x, which is what fermentation can do, but we think we can bring that to about 1x. And that means that we're going to drop about 80% of the CO2 emissions from making $100 billion worth of chemicals at $100 billion worth of market cap, 100 billion kilograms of chemicals, and you can already start to do the math. These are billions and billions of kilograms of CO2 that we can remove from the atmosphere if we can accomplish this. So I know the math gets a bit...
Who did that math? Raise your hand. Just kidding. It's a big number. So let's pass on to you, so Benjamina, with respect to cultured meat.
Meat is obviously one of the biggest CO2 producers, but I think on top of that, there's water usage, there's pollution, there's so many aspects. There's also antibiotics that we don't use in our system. So all of those we're able to massively reduce. We're now also working on proprietary technologies that allow us not just to reduce compared to conventional meat, but also beyond what the industry as an average is producing, so that we can really have the most sustainable solution out of the sector.
Makes sense. And why don't we jump to you first, Anastasia, because you're also working on essentially meats or replacing fats for meat. What kind of impact can you have? And by the way, just a side question, both of you, why don't we just all go vegan? Is that not the answer?
I mean, yeah.
Why don't we just all go vegan? I mean, we could try, but right now, there's not really enough variety, in terms of the vegan food that is available for people to really be able to give up, their cheese and their meat and their bacon and all of these products that they really, really like. So if we want to go vegan, which I think we will in the future, we need to have products that are at least as good as the meat and cheese and different animal products that are available right now. And this is actually what we are, I guess, both of us are working on in different ways. So in our case, we are working on fats, as I mentioned, mostly for plant-based foods, so plant-based meat substitutes, for example. There's already a lot available on the market. Most of them don't really taste quite like the real thing, and one of the main reasons for that is the fat. Because the fats that are used right now, they don't really have the same sensory properties that you get from animal fats. And this is something that we can really fix with our technology. So we can really look at what do you want the fat structure to be to get to these properties, and then mimic this with our microbes.
And obviously the assumption is that the end product will be substantially better for the environment, more sustainable, less water use, less greenhouse gas emissions?
Everything, yes. It will taste better.
Do you know roughly how much? Is it 10 to 1, 4 to 1?
So I guess it depends on what we are comparing it to. If we are just comparing in general plant-based meat to animal-based meat, then it's 90% reduction in terms of emission. It's several-fold lower in terms of energy. Also, I think 90% lower in terms of water usage. If we are comparing it to the fats that are being used right now, so for example, coconut oil is one of the most common fats that are used in these products. It will take a bit more analysis to get these specific numbers, but one, for example, is just land usage, right? Because one of the problems with coconut oil is that it requires a lot of land, it threatens biodiversity, and with fermentation, if we produce our products from sustainable feedstocks or side streams, we could use a tiny fraction, 1 over 10,000 times less of the land. So, yeah.
Yeah, that makes sense. And I think the last figure I remember on this was the animal agriculture industry is responsible for about 30% of global greenhouse gas emissions. So if you can take that down by 75 to 90%. That's absolutely huge. And Shara, a good segue to you, because you're also working on solving this problem and deforestation for palm oil. So maybe you could give us a sense of why this problem. And my impression before I spoke to you was that palm oil was just cheap, and that's why people used it. So why not just produce some other oil or have them switch over? But there's actually some value in palm oil. So maybe you could talk to us a little bit.
Lots of great questions. Yeah. So what do vegetable oils have to do with climate change, deforestation, and land use, as Anastasia started to talk about? So tropical deforestation linked to industrial agriculture today emits between 1 to 2 billion tons of carbon dioxide each year. 1 to 2 billion tons from carbon dioxide from industrial agriculture, which is the equivalent of 300 football field pitches of forest burned per hour. It's insane. It's totally insane. And when you're not burning forest, you've got to have a tremendous amount of arable land. So that's what's happening today. In addition, the world population is growing to 10 billion people by 2050, as we know. Vegetable oils are a core component of people's diets. And so today, that's a $250 billion industry. It's expected to quadruple by 2050, making it a $1 trillion industry. And we simply don't have enough arable land to make this amount of vegetable oil. So we cannot solve the problem within the existing framework of industrial agriculture. So 1.5 billion tons about per year CO2 emissions from industrial agriculture. Palm oil, which is our first product, is a major driver of that because the oil palm tree can only grow right around the equator, within about 5 to 10 degrees of the equator. So if you want more palm oil, which it's been growing at a tremendous rate over the last 50 years, that involves slashing and burning tropical rainforest. So there are lots of trees, which mean we're emitting lots of CO2 from the burning of those trees. They are also carbon sinks, as we know. So we're taking that and then we're burning the peatland, which is a double whammy on CO2 emissions. That land right around the equator is also home to some of the most biodiverse land on Earth. So there are thousands of animal species who are now losing their homes. The orangutan has become sort of the face of palm oil, as all 3 species are now critically endangered, single-handedly from palm oil production. There's nothing else that's driving it. And then there's some human rights issues related to people that live in that land as well. So you could solve the problem through agriculture. You could say, what is the sort of least invasive vegetable oil that we could use? The problem is twofold. One, if you do that, you just need a lot more arable land, and we should be using that land to make higher value products than simply vegetable oils. The second is performance, and so this is your second question. Don't we just use palm oil because it's so cheap? Price is certainly part of the reason that palm oil has become so popular, but so is performance. And palm has this really, really unique profile, essentially, which drives all of the things that you just alluded to. It drives its melting profile. If Nutella is sort of one of the most popular products that uses palm oil, it's what makes Nutella perfectly spreadable on your toast. And Ferrero has looked for an alternative, and none of them will cut it. And so what biomanufacturing enables us to do is a fewfold. One, we can use fermentation. We grow the product in steel tanks, and those steel tanks can be anywhere in the world. They don't need to be right around the equator. They don't need to be on arable land. They can be in a desert, and we can grow the product there. Two, it allows us to not only make a product which is as good as palm oil, so it can replace the function of palm oil, but it's good for human health and good for planetary health. We can also tweak the profile to make a sort of per spec or on spec oil that's better than what you can find from agricultural today. So we call these designer oils, which means palm oil is pretty good, but what I really want is a vegetable oil that looks like this, and fermentation is a tool which allows us to solve that. Cost is an important point. I think we have to be cost comparable to palm oil, and we believe that we can be at large scale. But performance is actually the reason that it's been so challenging to replace palm and other vegetable oils today.
That's really helpful. Yeah, I mean, I switched our family to the organic peanut butter, and my wife is always on my case as to why is it separating. So
exactly.
I get my workout mixing all that stuff up every week, but if we can solve it via just more sustainable palm oil, that'll solve one of my household problems,
Yep.
so thanks. Both of you, so Sharon and Anastasia, you're using yeast, or you're using cells to produce an output that, at least to the layperson, seems like a relatively limited set of organic molecules, right? Do you need to go through this effort of literally, getting yeast to do your bidding? Is there not a simpler way you can produce your outputs?
So I would say that no, there isn't. But it really depends on what we're trying to do, right? So like, if you're trying to make something that is like really specific, so, and okay, I will give our case as an example. We are looking for like very specific properties that are not found in plants. And okay, you could try to engineer plants to produce those types of fats. This will take forever, and we don't have a lot of time, and it will also take some land. So the nice thing about yeast is exactly like Shara said, like we can basically really manipulate it to get like very specific properties. So in the end, we have something that is not just sustainable, but is also producing something that is performing really, really well.
Yeah, I agree. Look, agriculture has tried to solve this problem and can't. I wouldn't have started this company if I didn't have to. I wasn't looking to become an entrepreneur. I learned about this 8 years ago when I was in Singapore, actually, and I was sent over with a mask like we are all wearing today, but not because of a pandemic, it's because the air was toxic. The air quality index in Singapore was over 400, which is super hazardous. Pregnant women were banned from walking outside, and this was because we insist on burning trees to grow a vegetable oil. It's completely insane. We've known about this problem for decades. 250 consumer brands have made public commitments saying, we're going to stop using conflict palm oil, which involves deforestation, by 2015, by 2017, by 2018, by 2020. And of course, they've all failed because there's no viable alternative. And that's why we have to solve it using biotech. My co-founder's a physicist, and so we started from first principles. And we said, if you're going to solve this problem, what has to be true? We believe yeast is a great way to solve it. And I think one statistic which is quite interesting is with trees today. So if I wanted to go start a palm oil plantation, I would go find some rainforest, I would burn the trees, I would plant my engineered seed, and it would take 7 years for that tree to reach peak production. 7 years. And then we know, oh, is this a good change? Is this not a good change? And then it's a really massive global infrastructure where it's shipped all over the world before it ends up in your soap bottle or your Nutella bottle on a grocery store. Our process takes 7 days for us to find the impact of that efficiency, and our whole process takes 7 days end to end. And so, yes, we're solving this performance problem. Yes, we need to solve the cost problem, but really this is about simplifying supply chains and making supply chains really transparent and taking out all those steps in 7 years of growth, putting them in one process, which can take 7 days end to end, which I think is really, really powerful for producing lots of different types of products for consumers in particular.
Makes sense. Fascinating. I guess let's go to you, Grant, because your approach is cell-free, and you deliberately are not using fermentation. Why is that?
Yeah, I think it's really important to point out that there's room for all of these solutions, right? So I'm about to say something which is very contradictory to what was just said, but at the same time, we're all trying to get to the same outcome. There are immediate solutions, and then there are kind of like next generation manufacturing platforms, which I think is what Fabric Nano is working on. So I'll go back to like how my co-founder and I started the company. He's also a physicist, but I'm an engineer. And to me, it was kind of crazy that people were trying to continually push microbes to do things that the microbes didn't want to do. So you're using genetics, and you're constantly saying, can I insert this gene? Can I get this expressed in just this way in this microbe? And today, the biggest companies in this space, like Zymergen, which will point to a very particular molecule and say, we can make that with a microbe, their best guess is, let's just collect more data and wait for the singularity for how we design microbes. It's really a dark art. People don't understand it. And with cell-free, what we do instead is we take the exact same pathway that would occur inside yeast. So we take the same 10 enzymes, 5 enzymes that go from sugar to your end molecule, and we use those proteins on an external support. Our company is using DNA. It's a very special support. But once we've done that, we can design these systems, these cell-free systems, to produce pretty much any chemistry we like. And the other benefit of using cell-free biomanufacturing is kind of to that supply chain question, which is, what is the input? a lot of companies will use very expensive sugars, like glucose. It's about 80 cents per kilogram. You might be able to get it for cheaper. But you're only going to be using a very well quality controlled upstream glucose. Cell-free systems, there is no microbe. So you don't get these problems where the glucose has some impurities and then the microbe misbehaves. We're using protein. The protein doesn't really care if there's a little bit of dirt or a little bit of impurity in your upstream sugar. And what this allows us to do is to co-locate industrial manufacturing facilities directly next to waste streams of sugar sources. And so we can use different upstream feedstocks, kind of eliminate a lot of the quality control. There is still quality control, but it's less stringent. And we can make those waste streams go 100% molar conversion to your end chemical with no waste to CO2. So we believe that that is the future technology on a cost basis. If I take a 50 cent per kilogram sugar, which is a pretty cheap sugar, and I convert only 40% of it to my end product, you got to multiply 50 cents by 2.5. You're already at $1.50 from your feedstock, which makes most commodity chemicals untenable. This is why the clean tech revolution of the past failed to make biofuels, to make bioethanol, to make all these other interesting products that consumers want in their daily lives, these products that have huge impact on the environment. We can't currently make those commodity products with fermentation. Now, that's controversial. But I believe that there is room for both companies in this space.
Yeah, well, it's clear that you really care about this topic and you're passionate about it, so definitely want to see you succeed. And to be honest, I think our research got us excited about both technologies, and it's clear your competition is not each other, your competition is the petrochemical industry, which is just way up here in terms of greenhouse gas emissions. You guys are working on very different problems, and there are enough chemicals to go around. So I think you'll all do your thing, and then saving the most complex for last. So you're not producing molecules or even small family molecules. You're producing an architecture. You're producing a system. Cells. With all the cellular components and all this stuff, and maybe growth hormones and growth factors to try and sera, it's actually seems, at least, again, I'm not an expert on this topic, it seems like a whole different degree of complexity. What are you doing that gives you confidence that the approach will work and will actually be economic, which is most important?
Yeah, so there's a couple of things. I think first to start with, you said, it has to be at least as good as meat. The way I see it, the problem with meat is not that it's not good. It's in fact so good that despite everything that it causes, 90+% of the planet continues to eat it. And so why we're going with cells is because we want to mimic it as much as possible to really get to that level, to get to that exact taste. We've done a lot of progress. When you think about the first burger that was ever made, that cost, $300,000. Today, there's down to the single digits per pound. So we've made a huge amount of progress. In our specific company, we brought down cost by, over 160 times in the last year. So we continue to make progress, and that gives us confidence that we can continue. We have clear pathways to get to those low levels. And the way we see it is it's also not an or solution, it's an and solution, right? We're working with hybrids, so there's ways of collaborating with companies like yourself. So there's a lot of solutions, and we need all of those solutions to work to solve those massive, massive problems.
Yeah, and that's amazing. So single digits already. So that's already potentially a product you could put on the market. People would buy it at that level.
Yeah.
It's not a $3,000 hamburger anymore.
Not anymore, no. So our specific company, we're not yet at the single digits, but the industry as a whole is.
That's amazing. So the good segue into another question is, do each of your products have to be cost competitive, or will people pay more because it's sustainable? Are we at a point where you don't actually have to undercut conventional products?
Can I take that one first?
Sure.
Our company is all about price. I think it's hard to shift consumer behavior, and we've seen that many times. It's very difficult to get people to give up plastic, single-use plastic even. To the best of our ability, we try to give it up, and yet we can't. So we need bio-based alternatives and sustainable manufacturing alternatives to compete on price. The demand curve is obvious. Consumers want these products, but we've never really been able to price them properly for people to mass adopt these sustainable or biomanufactured alternatives. And again, I'll go back to the clean tech revolution. You don't buy biofuels and you don't fill your car with something that costs 5 times the cost of an oil that you get from the ground. You use the oil from the ground because it's cheaper, and it's very difficult to get people to change that behavior. It's very difficult to get people to buy premium products. So for us, we think, make the same exact products that some of our competitors are making. You know, our first monomer diol glycol replacement exists today. Dow DuPont makes it, but it costs $3 per kilogram, and that's why no one buys it. Because a glycol from the ground, a glycol PEG, for instance, that you take from petrochemistry, you just crack this oil. It's a horrible process, everyone knows about that. But PEG costs $1 per kilogram. So there is no future without price parity. If you want to make an impact on the environment, you have to have price parity in mind.
That's if you're going for the mass market products, right? I mean, if people are buying cosmetics, paying a little bit more for some component, you'd rather do that and have a sustainable label.
There's a really funny quote, which is like, every biotech company starts out trying to change the world, and then they become a cosmetics company. And I mean, the impact on that scale is not really global, right? You need to be attacking commodities that everyone uses, and that's a price question. And that's why we...
Makes sense, yeah.
I mean,
That's
a funny story, I remember about 2 years ago, I was surveying people in the supermarket, just trying to understand, how they think. This guy had a lasagna in his, basket, telling me, I don't eat processed meat. I'm there like, well, I can see this is not an alternative, and you clearly do. Another one, telling me they don't eat meat and like putting it back on the shelf as they're talking to me. So I think, surveys and everything that we see, people want to do better.
You could have an impact just by having enough people asking those questions.
Maybe.
That's putting things back on the shelf.
Or you can be price competitive and actually get them to buy it, right? And I think that's the biggest thing, and fully agree.
Awesome, yeah. Makes sense. Shara, for you, I mean, I don't think the conventional palm oil industry will just take it, right? They'll keep going cheaper but I think in the end, presumably, because, as you said, enough food manufacturers have made these declarations and then failed, at some point they should be able to pay a little bit more to say, you know what, this is worth it.
I'll take a little bit of a different angle approaching this question because I agree with what both of you have said. Cost structure is important. Cost structure is a place of advantage for any business. It's important for us to have a good cost structure in which we can compete with the incumbents. There are a couple of things I'll point out. So one, you asked me about palm oil being cheap, and this is true for meat and other chemical markets too. Palm oil is cheap, but it is artificially cheap because there are a bunch of components of their cost structure that they don't pay for. Those things may include free labor, forced labor, which may include child labor, debt bondage, abuse of refugees, among other things. They may include free land. Big industrial palm companies are notorious for forcing smallholder farmers off of their land. They're often illiterate farmers, and they often come with signatures of farmers who are illiterate and or deceased, claiming that they have handed over their land, and instead they just force them off of it. And of course, it includes the carbon that they emit, the billions of tons of carbon dioxide that they do not pay for. So palm oil is cheap, but there's a bunch of stuff that they're not paying for. And I'm not dependent on them paying those things in order for us to be competitive, but I think it's really important that we spend a lot of effort solving those problems too and figuring out better alternatives to those. Because we've been on this race to the bottom on better, cheaper, faster, and like the definition of sustainable, it is not, and it has got to stop. There are massive consequences. So I think part of what we're doing, which is outside of the technology, is focusing on those things as well. And the good thing around willingness to pay, consumers care about that. And when consumers know, they want to push pressure up the supply chain, and they've started with these 250 brands. And so I'm quite optimistic that especially with younger generations who are doing better than all of us, I think that we will start to get a lot of pressure to change that behavior, and we'll see what happens with cost structure, but I think it's an important part of the problem to work on.
Makes sense. Yeah, I mean, I think this is just another clear reminder. A carbon tax would help all of you because it'll make it a level playing field. So if anybody out here has energy to spend on advocating for that, please do. And then Anastasia, in terms of product market acceptance, you know, do you see, and probably Benjamin, you've also looked at this, do you find there's any kind of resistance to the consumers adopting something that is, you know, cultured? Just briefly, have you done any surveys that give you confidence like the market will want this?
So, I mean, like right now, there is a lot of interest in alternative proteins and like new ways to produce food, especially among the younger people, like the millennials and the zillennials, Generation Z. So when we're talking about like the plant-based meat, which is what is available right now, the demand for this has been going up really, really quickly, like more than the supply of this. As we're moving forward and like really talking about replacing animal-based products with alternative technologies, probably there is going to be some resistance, I'm sure. Like you always have people that are resisting new technologies for producing things. But at the same time, like if you're comparing animal-based foods to something that is produced via cell-based or plant-based or fermentation-based, those products are objectively better for you. They don't have trans fat, they don't have cholesterol, they don't have contaminations from antibiotics, growth hormones, fecal material. So I think people will have a lot of reason to adopt these products.
Maybe we can quickly ask the audience, actually, how many of you would eat cultured meat? You know, raise your hand. Okay, majority.
I'll use that.
Yeah, there you go. I would too, although I am a vegan. I don't like meat at all anymore. Awesome, cool. And then let's talk about time to market, because it's super important not just that you succeed, but you succeed quickly, because you know time's ticking here. So how do you view getting to market quickly, and you know, does that include partnerships with incumbents, or are they not wanting to see your products come to market? Maybe let's start again with you, Anastasia, and work backwards this time.
Yeah, so like definitely we do have to partner up with companies that have competences that we do not have, especially, for example, when it comes to scaling up. The nice thing about fermentation is that there is a lot of infrastructure available already, so we don't necessarily have to invest in our own infrastructure just to scale up. So this is definitely...
These are like contract manufacturing organizations. You can use third parties.
Yeah,
you don't have to build your own factories.
Yeah, like so there are contract manufacturers to produce the products. There are special scale-up organizations to just take it to industrial scale. Of course, if you're working with contract manufacturers, it's going to be more expensive. So this is not a long-term solution, but just to get to the market, it's a very good option.
Makes sense. And Cheryl, how do you get to market fast?
I would say my biggest lesson from CleanTech 1.0 is don't spend 10 years and billions of dollars in a vacuum. It's really important to be solving product and market risk in parallel to solving technology risk. You can't just solve technology risk and say, oh, and then when we get there, everyone will buy it. So you've got to work on all of those things. And so I think in the beginning, it's very much technology risk. And then we're sort of at this stage now where we're really focused on product and market. So our biggest challenge is getting down the scale curve, which will get us to comparable cost structure. It'll also allow us to make sufficient product to sell it. And so by end of year, we're doing our first commercial scale demonstration of fermentation, which will be in less than 3 years, which is a pretty quick timeline. And that will enable us to have an attractive cost structure and metric tons of product that we can actually get to customers. And so I think that the takeaway of solving product and market at the same time as technology is really, really important, and getting feedback from existing market, whether that's consumers or big brands or chemical companies, whoever it may be, is really important to do that early. And there's lots of reasons they won't partner with you early, but you've got to get that feedback anyway so that you're not working in a vacuum.
Yeah, no, that's a great insight. In Silicon Valley in the early 2000s, we said build it and they would come, and
Yeah.
figures build it and they will eat. But that's not the way to go
Yeah.
about it. You need to actually educate the market, understand how to get to market.
Know them, know who
Yeah.
they are and what they actually want instead of just what you tell yourself. Yeah, that's
Yeah.
right.
And then, Benjamin, would you be selling through, for example, Tyson and these existing meat companies, or do you view a direct-to-market approach as being the way to go?
So we're looking to start with directly ourselves. Now, once we produce enough quantities, it's definitely something that we're exploring, but we want to have as much control as possible over the final product. It's something that's new, and what we found as well is that a lot of the large companies, what they wanted us to produce, so do the really hard part of producing all of those cells, and then sell it to them so that they can create the products and take it from there. So it wasn't just, we could do IP and go and figure it out. As the industry matures, this might make sense, but we wanted something where we really have control, and we have as well a bunch of amazing food scientists in the company that really are breaking grounds, not just on the cultivated meat side, but also on the food science side. So excited about both.
Makes sense. And Grant, obviously, you can leverage the existing industry, or you can try and go full stack. What are you planning on doing?
Yeah, I think, again, I'll be contrarian to the rest of the panel. In my humble view, because what do I know? First company, I think we're all learning as we go through this process, and we have to be humble when we approach customers and try to understand them. But in my view, you have to get the buy-in of the existing industry. There's no reason to fight the industry. Why not enable the industry? So one of the things we really focused on with our product, which is now ready to start shipping, we're hoping to get some basic versions of our product out by January. Kilogram scale is big for biotech. I think everyone here knows that. But what we're looking to do is we're looking to really partner with existing manufacturers who have packed bed flow reactors. And so that's a huge deal for us, is being able to drop our solution into those systems. And why do we want to do that? Because together with the chemical industry, which has a lot of social and particular tailwinds to try to adopt technology like this, we can have a bigger impact more quickly. I think all of us have big ambitions for our companies, but if it takes us 10 years to get there, it's not going to be enough, right? Like, we have to do this in a 5-year horizon, which is already difficult because no one's ever done it. We're startups, but we need to try to have that impact quickly. And the way that I think about doing that is enabling the chemical industry, which even in the world of cell-free is quite contrarian. I mean, there's a company out there that is a competitor to ours. They do similar things, but with a different technology stack. They're called Solugen, and they raised $350 million Series C recently. And so our technology can approach the same exact chemicals that they approach. We can do things that they can't do, but they're trying to do a full stack integration and trying to build reactors all over the world. We think it's much better to get the buy-in of the chemical community and try to get these chemical companies enabled to start building bio-based solutions and bio-based materials. And so that's really how you have the impact quickly, right?
Well, the industry are also your
involved.
customers, right? And the direct competitors producing the same exact molecules. You don't need to work with them, but you have consumers higher up the stack, much as you guys, have customers that are within the industry, and you can sell into that stack later on. So just very, very briefly, do you feel like culturally you've figured out how to execute internally? Because I know for many deep tech, frontier tech companies, you have cultures, an R&D culture, and you have an engineering team. How do you get R&D people to deliver? Have you cracked the nut? And again, we don't have a lot of time, so just briefly.
Quick one. Charles is completely right. You have to build product quickly. You have to integrate everyone into a product quickly, service an MVP. Everyone binds together and tries to build something that consumers can actually use. That's the most important part, even for a biotech company. Don't have these aspirations that 10 years from now it'll all work. It better work as a basic product very quickly, and that's a good way to centralize your team.
Yeah, I think communication. We've done small things, but just lunch and learn about what the other teams are doing and learn more. And I think that just really, really helps to understand where the other person's coming from.
Makes sense.
Yeah, it's hard. There's a science culture and an engineering culture, and I think it really hits its head when we're thinking about how to solve a specific problem. So I like what you said, and we also have good unifying goals with cross-functional teams, and everyone from strain engineering to marketing is responsible for that objective. But when it comes down to how do you solve this problem, you get really different answers from scientifically trained and engineeringly trained. And honestly, I think that's your job as CEO is to prioritize and say, like, what is the most important thing here, and what are the risks, and then make a decision. But it's not easy, so I'm hiring someone to lead my R&D team that can integrate these different groups.
There
that
you
know
go.
about
I'm sure
it.
there's a few sounds.
We're also hiring. Everyone's hiring.
Same.
Good plug.
Yeah.
Yeah, I agree with everything that the other panelists said. So communication, clear goals, clear milestones, and of course, the R&D team has to understand why they are doing what they are doing, like have the bigger picture in mind. And in general, just when you are designing your R&D program, you have to think about what is production going to look like at scale, right? So, for example, in the case of like fermentation, what is the bioprocess going to look like? What kind of issues will you run into potentially as you're scaling up? And you have to think about these things pretty early on and try to solve them.
Makes sense. Yeah. Oh yeah. On the companies whose boards I'm on, I've yet to hear an R&D team enjoy sprints or embrace that idea. Oh, they don't get us. They're asking us to do 2-week sprints. How can you do that with science? So last question. We're a little bit over time, but just wanted to end on something a little bit different. So beyond what you're doing individually, maybe you could each tell us something you're excited about in the sustainability or climate space, something you think has potential to solve some of these problems we're looking at. And let's start with you, Benjamina.
I'm excited about all of those guys. I'll take the easy one, but it's true. I think I'm excited about the amount of, solutions that are out there, and I think tackling things from every single aspect, because it's such a massive problem. We need not one solutions, but really, really many.
Sense. Sure.
I have two, sorry. I looked at your shoes and it inspired me. I think one, like companies like Allbirds and companies that are really going hard on consumers and saying like, we can make beautiful, amazing products that don't have all these sacrifices. Big fan of that. There's a lot of work that needs to be done there. And then at the other end of the spectrum, I think for me is nuclear. For problems that are just really hard and some might say impossible, like that's to some extent what we're doing also. We wouldn't be doing this if we didn't believe it's technically possible, economically possible, and people will buy it. Nuclear is also super challenging. I don't know when we'll solve it, but I'm really, really glad to see a lot of brilliant people and tons of resources starting to be thrown at that problem so that we can move faster to get an answer on it.
Yeah, I'm also excited by all of the innovation that is happening across the different sectors that we see here. And also in general about like this momentum that we really feel now towards sustainability, right? Like more and more people are aware of climate change and that we need to do something. So you really see like a lot more initiatives. In terms of specific technologies, I'm intrigued by carbon removal, which is I think is also the next session. So we will see. Yeah, I'm really excited to learn more about it and what we can do with this.
Cool. And last. Grant.
Last word, really. I'll come back to something you said, which was, at the board level, it's very difficult to get a team moving, especially a science team, along things like KPIs and to measure success in companies like ours. But I think that the space that I'm most excited about is just accurate carbon measurement, like these companies that are coming along, and I think Silvera is one. There's a few others. Connect is another EF company that just got created. I see some EF faces smiling back there. Just measuring our carbon, our carbon emissions, our GHG emissions. What you can't measure, you can't improve, right? This is a Peter Drucker quote. I think it's really important when managing a very deeply technical business. We can measure, carbon emissions and GHG emissions, and yet the solutions are, not really sufficient for use and for purpose. So if we get there, if we can measure these things more accurately, I think we can impose things like carbon tax and carbon credits on the industries.
Awesome. Amen to that. Well, I think the fact that despite the pandemic, we have a really good showing here today also is a cause for encouragement. Thank you for organizing, Stephen, the event, and thank you guys all for coming from far and wide to join us. Best of luck.